Okay, today we are going to work more with quadratics, and we're going to solve them by graphing, by factoring, and also by using the quadratic formula. So first I'm going to make something that's like a Frayer model, and I don't know if you've used a Frayer model in other classes before or not. So this is a Frayer model, but it looks a little different than your typical one if you've done one before. If you've never done one before, you probably have no idea what I'm talking about. So I'm going to start with a blank piece of paper, and I have it turned horizontally, and this can be notebook paper. It can have lines on it. It doesn't matter. I'm just using printer paper. So I'm going to draw a bubble in the middle, and then I'm going to divvy my paper into 4 sections, and I'm not using a ruler because I don't care that much. But if you feel like you care that much, which is fine, feel free to use a straight edge of some sort. Okay, and we are going to title our Frayer model Solving Quadratic Equations. So solving quadratic equations. And I'm just going to give you an example of one. Two x squared plus x equals 6. This is an example of a quadratic equation because the highest exponent is a 2. Now, we've been talking the last few days that if you solve by graphing or factoring or with the quadratic formula, that this always needs to say equals 0. So how can I make this go away? How can I make this 6 turn into a 0? By subtracting it. So if I subtract it, I would have 2x squared plus x, and if I subtract it, it would say minus 6, and now it equals 0. And once you have your quadratic set equal to 0, then we're ready to solve it by whichever method we would like to solve it with. On this paper, we're going to solve the same equation all 3 ways that we know: graphing, factoring, quadratic formula. So before I get to that, I'm going to start with some general info. I'm going to go ahead and blow this up. So you can see a little bit better. Okay, so our standard form for our quadratic equation is ax squared plus bx plus c equals 0. And I only wrote it like this so it would stand out to you a little bit more. A is in front of the x squared, b is in front of the x, and c is the constant, the number that doesn't have a variable behind it. So that's our standard form for all quadratic equations. And then we haven't talked about this, so now's a good time to talk about it. We have 3 possible solutions that can happen with quadratics. The first one is if a graph touches the x-axis in 2 locations, then we will have 2 solutions. And a lot of the problems that we have solved have had 2 solutions. And that's because when the highest exponent is a 2, then most of the time we do see 2 solutions. Okay, another thing that can happen is that the graph will just touch the x-axis in 1 location, which means you really only have 1 answer. but it's probably a situation where it's the same answer, you just would get it twice. Okay, and the third thing that can happen is if we have a graph that never touches the x-axis, and if it never touches the x-axis, then there is no real roots. There are two solutions to this, but they're two imaginary solutions, and like I said the other day, you won't learn about that until you get into Algebra 2. So these are the three things that can happen. The graph can touch the x-axis in two locations, which means you'd get two real solutions. The graph could touch the x-axis just once, which means you just have one real solution. Or the graph could never touch the x-axis, which means there's no real roots. Okay, and then we have three ways to solve. I've already mentioned them. Remember what I said? There's graphing, there's factoring, and the third way is what we learned yesterday, the quadratic formula. So three ways to solve: graphing, factoring, and the quadratic formula. Okay. First thing I'm going to start with is graphing. So I'm going to come over here and I'm going to write graphing down. And I'm going to go ahead and use this problem as my problem. And I'm going to use the one where it says equals 0. So 2x squared plus x minus 6 equals 0. I'm going to go ahead and make a coordinate plane. So I'm going to start putting some tick marks on here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, next thing I'm going to do is I'm going to grab my handy dandy calculator and I'm going to go to the y equals button and I'm going to type that equation in. 2x squared plus x minus 6. And then I'm just going to take a peek at it. I'm going to look at the graph. And it's kind of hard to tell where it hits the x-axis. This one looks like a -2. This one looks like a 1.5. So it's kind of hard to see there. So I'm going to plot some points, some specific points. So I went to the table, I went second graph, and I'm just going to plot some points that I see there. So first I'm going to plot -1, 5. So I'm going to go left 1 and down 5. I'm going to plot 0, -6. So I'm going to drop down to the -6. I'm going to plot the 1, -3. I'm going to plot the 2, 4. And I'm actually going to arrow back up. I'm going to plot the -2, 0. Okay, so I do know that -2 is one of the solutions, because I know wherever the graph touches the x-axis that the y value is 0. So when I find that the y value is 0, I know that that is one of the answers, -2 right there. And then let me go ahead and plot -3, 9. Of course, I'm just going to kind of eyeball that. That'll be way up there. Okay, let me go ahead and make my graph. Okay. So it kind of looks like my answers are x equals -2, and like I showed you earlier, it looks like a 1.5 It's kind of hard to tell for certain. So I'm going to do something that we've never done before to see if it is. I'm going to go to where it says Table Set. Table Set's in blue above Window. So since it's in blue, I need to go Second Window. And down here where you see this, the 1 there, that means it's going by increments of 1. I'm going to go down there and I'm going to go and type 0.5. So the table goes by increments of 0.5. So the table will go by halves. And I'm going to go back to my table. And I'm going to see if that really is a 1.5. So let me look. And here it is. When the x is 1.5, the y is a 0. So I know that 1.5 is the actual answer. So I'm going to write that down. X equals 1.5 as well. Okay, so just to fix that, because most of the time we don't want it by 0.5s, I'm going to go back to Table Set. So I'm going to go Second Window. I'm going to come down here and I'm going to put that back to a 1. And this means I'm going to go by increments of 1. So now it will be fixed. Okay, so there's solving by graphing. I can just plot various points that I get from the table, and wherever the graph touches the x-axis, then those right there are my solutions, my roots, my zeros, and my x-intercepts. Okay, now let's solve the same problem by factoring. Okay, so I have the problem 2x squared plus x minus 6 equals 0. Okay, when I solve by factoring, what's the first thing we always look for? A GCF. Do I have one? Nope. Next thing, 2 terms or 3? 3 terms, so what am I going to do? A times C rooftop. So what do you get when you take your A times your C? Negative 12. What do you want them to add to be? Positive 1. Okay, what 2 numbers multiply to be negative 12 that add to be a positive 1? 4 and negative 3. Can I shortcut? No. It's not a 1 in front, so since it's not a 1 in front, I have to do it the long way. So whatever this first term is, I just recopy it. Instead of using the middle term, I use these 2 guys over here. So I'm going to write a positive 4x, a minus 3x, and then I'm going to drop down the minus 6. Okay, and then at this point, I'm going to cover up my back 2 things, and I'm going to look at my first 2 pieces. And what's your GCF out of your first 2 pieces? 2x. Once you find your GCF, build your parentheses behind them. 2x times what is 2x squared? X. 2x times what is 4x? 2. Okay, let's look at our back 2 things. What's your greatest common factor out of those 2? A 3. If this is x plus 2, what's this one? X plus 2. Come back. What kind of 3 does he need to be? A negative 3. Okay, now, what goes in one set of my parentheses? X plus 2. What goes in my other set of parentheses? 2x minus 3. And now that I'm done factoring, I'm ready to solve it. So, when I go to solve, I want to know what do you get if you set x plus 2 equal to 0. And I want to know what do you get if you set 2x minus 3 equal to 0. So once I have the problem factored, I set this factor equal to 0, I set this factor equal to 0, and then I solve these 2 equations. And so hopefully you can solve these equations in your head. What do you get when you solve this equation? X equals negative 2. And what do you get when you solve this equation? X equals a positive 3 halves. Because you would add 3 to both sides, and then that makes 2x equals 3. You would divide both sides by 2, which makes x equals 3 halves. Is 3 over 2 the same thing as the 1.5 that we got when we saw it by graphing? Yes. Okay, so now that leaves us with the quadratic formula. Okay, so quadratic formula. And I'm going to go ahead and use the same problem. 2x squared plus x minus 6 equals 0. Let's go right ahead and write down what our quadratic formula is, and we can practice singing. So you can either just listen to me sing or you can sing with me. That would be more exciting. You should sing with me. Are you ready? X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. Since my problem says equals 0, I'm ready to go. What's my a? 2. What's my b? 1. And what's my c? Negative 6. Okay, now I'm going to do exactly what the problem tells me, or the formula tells me. So x equals the opposite of b. What's the opposite of b? Negative 1 plus or minus square root. Okay, now I want to take my b and square it. So what is b? 1 minus 4ac. So what is our a? 2. What is our c? Negative 6. All over 2a. What do you get when you take 2 times a? 4. Okay. Next thing I want you to do is I want you to take everything that's under this radical and put that in your calculator. Remember, this thing here is called the discriminant, just in case you need to know that. So let's go ahead and type that into our calculator. So parentheses 1 squared minus 4 parentheses 2 parentheses negative 6. And that makes 49. Okay, so I'm going to recopy that x equals the negative 1, the plus or minus, the square root. I got a 49 when I calculated that underneath, and recopy the divide by 4. Next thing I want to do is I want to see if I can actually take the square root of 49 and get something pretty. Can you take the square root of 49 and get something pretty? Yes, I can. You get a 7. So negative 1 plus or minus 7 over 4. And now I'm ready to get my two answers. One with the plus, one with the minus. So let's do the plus first. How much is negative 1 plus 7? 6. And what's 6 divided by 4? 3 over 2, or 1.5. Okay, now let's do the minus. What's negative 1 minus 7? Negative 8. And negative 8 divided by 4? Negative 2. So you can see that we get the same solutions no matter how we solve it, graphing, factoring, or quadratic formula. But, like I said the other day, you can't do all problems with graphing. You can't solve all problems by factoring. But you can solve every problem out there with the quadratic formula. So that's the whole point of learning the quadratic formula. And here we are. These are our 4 methods for solving quadratic equations. So let me show you what your assignment is real quick. Okay. On the front page, you have 3 problems to solve, and you're going to solve them by graphing, by factoring, and with the quadratic formula. Do make sure that they say equals 0 before you begin. So like this guy, not a 0, so you're going to need to fix that. Okay, so that's what the front side is about. So you have 3 problems to do, but you're going to do those problems by graphing, factoring, and with the quadratic formula. You'll definitely probably want to do the graphing first on all 3 of them, just so you have time with the graphing calculator before class is over. Factoring and quadratic formula, of course, you can do those at home if you run out of time. But do the graphing first for all 3 of those. Okay, and then the back side these three tell you to solve by the quadratic formula. I say let's go ahead and just not do 10 and not do 12 because you're already doing 3 on the front with the quadratic formula. So let's go ahead and do 11. And then that leaves you more room to write. Do make sure it says equals 0. Be careful here. That doesn't say equals 0, so you're going to want to fix that. Okay, number 13 is asking for the solution to the system of equations. So that is something that we went over a while back. So if you guys remember how to do that with the graphing calculator, I want to make sure you go ahead and do it with the graphing calculator, but I will definitely go over that with you next time I see you. And number 14, it was supposed to be multiple choice, and it was supposed to give you the selection for the system of equations, but since we can't see the answers, I want you to just see if you can write your system of equations. So try to write your first equation and then try to write your second equation for what you read right here, and we won't worry about it being multiple choice. Just try to write your own 2 equations for the information that you see here. Okay, so 13. I do want you to try it, but if you can't remember how to do it, it doesn't bother me if I run through that with you again in class. And then only have to do number 11. And then I do want you to do the whole front side. But do your graphing first. That way you have the graphing calculator right here. Thank you.